All right, welcome on in, everybody. So we got a few people, more people should be kind of coming on in here. So welcome. We're kind of getting going. We talked about statistics a little bit last time, but I want to make sure, some of these basics at the beginning, most of you have picked up from watching the videos themselves. But there are certain key ideas in statistics that without understanding those key ideas, the rest of it, you'll kind of think you get what's going on, but you're actually missing the actual point of statistics, and you just won't really be able to make sense of it. So today I'm covering some pretty basic ideas, but I'm doing that to make sure that everyone really gets it, right? To make sure that everyone understands what I'm talking about. So it's entirely possible you're going to watch today's lesson and go, I totally got that from the videos. Well, why are we going over this again? But it's because I'm going to fill in a little bit of information really to make sure that you understand what's going on. Because if you don't really understand the point of sampling, then statistics is out the window, right? You can memorize how to make a histogram and memorize these different things, but if you don't really get the point of sampling and why it has to be done in certain ways in order for it to really be valid, then everything we do the rest of the semester is just easy to misunderstand and not really get the big picture of what's going on. So I want to make sure that's what I kind of want to do today. And I didn't check this morning. I saw there was a little bit of a rise in the number of people signing up for the homework. Yesterday, I think a couple more people did. Please make sure you're signing up for that homework and getting that taken care of. The sooner you do it, the better. And then we can start moving ahead with things for the semester. And you can have more time to do your project rather than less time because we're waiting on people to get certain stuff done. So move ahead with that. Oh, sorry about that. Excuse me. Where am I? Oh, right. So I'll be going over some ideas right again. And if you think, if you go, oh, these are pretty basic. He's just gonna talk about the stuff from the videos. Probably I'll be throwing stuff that isn't in those videos in there, but just kind of realize I get this is a lot of repetition early on. But this is how it is with a lot of statistics. You can go in and think you understand something, but you're still like missing the most important piece. And you're like, no, I can do a hypothesis test. I get a p-value, and then I compare it to our relative value, our cutoff value, and then I see what we should do, and then we either reject or fail to reject. I get all that, but there's still a few things there that if you don't quite understand what's going on, you're just memorizing a process. You're not really working through it and understanding the underlying statistics, okay? But I know we're still early in this class, so if people have questions, if people are having difficulty with whatever, make sure you sign up for that, or that you write your question in chat, or stick around after class and talk to me after class, and I can try to make sure you're going in the right direction. But make sure you're getting all those things we talked about squared away. So a few basic definitions we're going to need. We're going to use these definitions a lot throughout the semester, so really good that we understand these. So one is data. What exactly is data? Data are collections of observations, such as measurements, genders, or survey responses. Excuse me. And we just keep track of those things. So we can have data that's small, right? The data we're collecting for this class, where we'll have around 40 responses to your survey questions, that's considered relatively small. In most cases, you sometimes see smaller than that, but you'd hope to be at least as big as what we're going to do in here, which is about 40 responses. And then you have all the way up to what you might have heard the term big data. And that's because with the way computers have changed in the last 20 years, we're able to handle types of data that we have never seen before, right? This is new to the world. So, they used to be able to, collect sets of data that were maybe hundreds of thousands, maybe even some with millions of data. But you go back 20 years and computers were quite a bit more primitive than they were now as far as the amount of information that could be stored on them, right? We can store massive, massive amounts of data, right? Even just the RAM in your computer can hold more information than like the hard drives in the 90s, right? Like by far. So we are now able to just store, you as an individual at home could store a terabyte of data. You can go out and you can buy a 2 terabyte hard drive and you can fill it up with data if you want. That wasn't really possible for the private individual 20 years ago. It was barely possible for like big companies and stuff. But with Facebook and Google and Apple and all these companies, they are collecting massive amounts of information on all of us, right? And I think a lot of people don't realize exactly how much data is being kept on them. When your phone is in your pocket and you're not even using an app, data is being transmitted about you, right? There are still apps collecting data in your phone and sending it to Facebook and Instagram and all these different apps that you use, and it's collecting information about you. And they use that information in order to get you to click links and buy products and look at ads and stuff like that. So if you just kind of imagine, the Facebook app is out there collecting data on its users every day, you can imagine that is a massive amount of data that's being collected on a daily basis, right? And Google has the same thing, right? They've indexed the internet. How is all that done? And you've seen, you can go online and you can see these data storage areas where it looks like the room goes on forever, and it's just servers and hard drives for as far as the eye can see. So, that's actually a pretty good area to go into if someone's looking for work. You're still trying to decide what you want to do as a career, getting yourself a degree in statistics and working at one of these companies, pretty decent job to have compared to a lot of what's coming down the, in the next 10, 15 years, what our workforce is going to look like as far as jobs available is not super, it's not a super happy thing to look at. But people who want to go into statistics, you'll make money. You'll get a paycheck and you'll be able to afford a house and a car and stuff like that. So anyways, something to look at, something to consider throughout this semester while you're doing statistics. Like, is this a thing I could see myself doing? Because it's an area where you can do pretty well for yourself. Okay, what is statistics? That's the name of the class. Statistics is the science of planning studies and experiments, obtaining data, and organizing, summarizing, presenting, analyzing, interpreting those data, and then drawing conclusions based from them. That's a lot, right? That's a lot of things in there. All those pieces are necessary. A lot of times there's this idea that, well, I calculated a mean, so I'm doing statistics, right? Not really. Like your project that you're working on start to finish, where you create the questions and they're going to get in a survey. You're going to get the data back. You're going to analyze the data. You're going to run different tools on them. You're going to make conclusions. That whole thing is all considered part of the statistics. At that point, you could say, yes, I'm doing statistics. Calculating a mean, sort of doing statistics, but it's sort of not really what we mean. When we mean statistics, we mean well-rounded, the whole thing. And that making conclusions, drawing conclusions based on what you've done, that's one people forget a lot. And I tell you, that's one that when I'm grading the projects at the end of the semester, those people who have done a good job, assuming you've done a good job on the rest of it, if you're drawing conclusions well, that's probably an A project, right? That's the way to get an A project, is you do all the other stuff good, and then on top of that, you draw some meaningful conclusions from your data. Then that's what I'm looking for in these projects, right? That's an A probably. So it's basically everything we're going to be doing for the next 14, 13 more weeks is statistics, right? So what's a population? A population is the entire group that we're trying to study. So a population could be lots of things. We could be trying to ask questions about the population of the United States, right? But even then, it's kind of tricky because as you've seen this, we're going to talk about the word census in a minute. Last year, there was a lot of stuff in the news about the census that we run as a country. And then the question came up because sometimes the people that are in power want things counted a certain way, right? Because it works for them politically, so they can gerrymander and different stuff going on politically. How do we count that? Do we want to count the people that are standing on land that is considered United States? Is that what we want to count? Or do we want to count United States citizens, right? This was literally the question in the news. The administration was trying to change the way we've counted things since the beginning of our country. So the Constitution says the census counts the number of people in the United States. Notice it never said in there United States citizens. So you always have to be careful when you're defining something in statistics. Be specific and ask yourself, well, what's our goal? What are we really doing here? Are we counting the number of people who are standing on American soil, or are we counting the number of people who are American citizens, right? And that was literally litigated. It was in the courts, about if that change could be made or not. But a lot of times when people hear about they did a census, they don't stop and ask themselves, what did we really count here, right? Whenever you're involved in statistics, either doing statistics or interpreting statistics, you always want to know, well, what exactly was done? What are the details, right? What type of people did you count? Did you just count American citizens, or did you count all the people that are here? Like, what are we counting exactly? And then you know what your population is. We could say, we could be doing, we do this actually on campus. I'm on the academic senate, and sometimes we make decisions about what's going to happen campus-wide, right? So a few years ago, this is an example I use a lot in statistics because it sort of relates well, and people, it's a good example. We changed the tobacco policy on campus, right? So or rather, I should say the chancellor did, but the academic senate made a recommendation about what we thought should be done. And then actually he was the president at the time. He's the chancellor now, but he was the president of the college at the time. He made the ultimate decision, but we made a recommendation. So as the academic senate, we might wonder, well, what do the students think? What do the students think about a tobacco ban? Do they want a full tobacco ban? Do they want there to be 5 stations on campus where people can go smoke? Because that's what we used to have, right? And they were in not great spots. So if someone was smoking in this spot, it wasn't going to bother you because, it was kind of in areas that were a little bit gross, and they were like a few hundred feet away from where anyone else would want to be. That was the old system, right? Or you could just have people. You can't have people smoking everywhere because I forget what the state law is about state buildings and stuff like that, but you can only be so close to the entrance of a state building. But anyways, we had to figure out, well, what should the policy be for school? Well, then it makes sense. Let's ask the students, right? I mean, ultimately a college is about the students, so let's see what they think. And so then you would go and you would ask them. So in that case, the population would be Ventura College students, right? That's the population we were talking about when we tried to do some statistics in order to figure out if people were for or against a tobacco ban and stuff like that. So your population could be, if you were talking about something different, your population could be first-year Ventura College students. Or it could be graduating Ventura College students. See, there's lots of ways. It depends what you want to look at. Do you want to know about students who are graduating and going to university? Then your population would be graduating Ventura College students, right? So you can define that population however you want, but you should be aware of how you're doing it. Like you should think it out ahead of time at the beginning of your project. Now, or at the beginning of your study. For what we're doing in this class, I've kind of decided what your population is because we're limited in how we can collect data. So your population is our class, right? That's ultimately our population. We can kind of pretend like it's bigger than that, but really the population that we're studying is kind of our class, which is also our sample, which is why there's a few issues with the way we're doing the project in this class as far as like, we wouldn't publish this and expect it to stand up to scrutiny, but at the end of the day, the project is just it's a learning tool. You go through and you learn all those tools, and some of what you come up with might be valid. Like it might be, you might be able to draw those conclusions, those conclusions might be true about the greater population of Ventura College, but the way we're doing this is kind of based on convenience. So it wouldn't be bulletproof. It wouldn't be like we would expect this to stand up scientifically, but that doesn't mean it can't be enlightening in some way, right? Okay, now we get to an important distinction because people really want to understand or need to understand what a sample is. And I find that throughout the semester when I'm talking to people, I still run into people who don't understand what a sample is. Okay, so this is important. A census is when you ask every single person in the population. A sample is when you take a smaller group of the population and you ask them something or you study them in some way, and you try to make that apply to the whole population. Okay, so we just talked about the United States Census. The way the United States Census is supposed to work is that every person in the country, whether they're a citizen or not, every person in the country is supposed to be counted, right? So the census means everyone gets counted. That's really hard to do. That's why the census is the United States Census is extremely expensive, and why it never works 100%. You can imagine there's around 340 million people in this country, something like that. It's pretty hard to track down every single one of those 340 million people and keep track of them. You're gonna miss stuff, right? Stuff's gonna get missed. So censuses happen very rarely. It's very rare that you're able to pull off a census. Now, it's really important in our country that the national census goes well because it affects things like districting, right? It affects how many representatives your state gets. Like, I think California is set to lose one, and some other states will pick up. Some states are going to lose, some states are going to pick some up, just depending on how the population is changing over time. So it's really important, right? If you're in California, which I think almost all of us are, and you're set to lose a representative in the House, that's not good news, right? If you would like to have as much representation as you can get. So the census is really important, but most things aren't done that way because it's extremely expensive. It's extremely hard to do. If you followed the news at all last year and you heard about the census, I mean, there were more legal battles than just the one I mentioned. There's all this work going on to try to undermine the census at the same time that we're trying to conduct it. But the powers that be, they have interest in how the census comes out, and so they're trying to change different rules, and it ends up in the court and stuff like that. It gets very messy. But fundamentally, that's what the census is that every single individual is supposed to get counted. Okay, what you run across much, much more in statistics is a sample, right? A sample is where you take a small group of people or things, whatever you're studying, right? It doesn't have to be people. And you study those, and then you try to do it in a way where you think that's representative. And that can be really, really difficult. So even taking a sample, a sample can take a lot of time, a lot of energy, and a lot of money. So that's why it's important, that you plan out, if you're doing a real world statistical project, where you really needed it to be good for work or for research or whatever you're doing, you have to do a lot of planning before you even pick your sample. Because, for instance, let's say we said, well, let's think about students who are doing online classes. We want to know about online classes. So why don't we just take Dr. Frederick's class and we'll ask his class what they think about certain aspects of online teaching and being in an online class, and then that'll be our sample. That's good, right? No, because remember I talked about last time randomness? Like, you can't just pick any small group and expect it to be representative, right? Because the fact that you all chose to be here, and that's kind of the thing, right? You all chose to be in this class. No one dragged you in here and forced you to take this class. You signed up for it. So there are things that all of you have in common. You're willing to take a class Monday, Wednesday morning at 8 a.m., right? That sets you apart from people who are not willing to take a class at 8 a.m. Maybe some people work at night, and this is the time of day that they really need to sleep because they have to go to work at, or whatever, some weird time, or they're working during this time or whatever, right? That sort of sets you apart. So the answers we get from you are not going to represent those people, right? They're not going to represent people maybe who are taking a ceramics class online, right? They're not going to represent everybody. So what you generally try to do is randomize things. So there should always be randomization in what you're doing. If there's no randomization anywhere along the line, that's a pretty big check, like a red X against what you're doing. It's not a good sign. Now, again, the sampling in this class was not randomized, but again, we're not trying to publish our work here. We're just trying to understand how these things work. And as for a learning exercise, this will be plenty good in our class. Okay, but you should realize if you go forward and try to do something, you have to be careful about how you pick your samples. So, voluntary response samples or self-selected samples, sometimes called convenience samples. Basically, I hate to say it, the easier it is to collect data, probably the worse that data is. That's not always the case, but like the easiest thing you could do, take a poll, throw it up on a website, see what you hear back, right? That's a convenience sample. It's very convenient to run that sample. It takes almost no work. People are deciding if they want to take it or not. So generally what you're going to get is the people who respond are the ones who feel most strongly about that topic. And then depending on which site you put it, you're going to get different responses. I think I mentioned this before. An example would be putting a presidential poll on Fox News site versus putting a presidential poll on MSNBC. You're going to get very different results. Same exact poll though, right? So anytime you see, when you tune into something and they're like, well, we ran this, sometimes they'll call them like internal polls to make them sound a little bit more legitimate. They'll give them different names. But whenever you're watching something and basically the company just ran its own like website poll, you might as well just change the channel or change the station or whatever you're watching. Like everything being said after that is probably meaningless, right? There are ways where companies can run polls, but they don't usually do them themselves, because what you do is there's companies out there that you can go to and you can pay them and say, we need a poll like this run. Can you do it? And then that company says yes. And then they have all the tools. Their whole system is set up to run stuff professionally. It costs a lot of money, but they'll take care of it for you. And then the data you get back will be largely reliable because those companies are professionals in figuring out how to do stuff. So a lot of times when you see the news, a news channel talking about a statistic, somebody along the way, whether it was them or another television or another news agency, or perhaps it was some lobbyist groups. Lobbying groups do this a lot, where they pay some company to do a study and then they can use those results, right? You can do stuff on your own, but you have to have, that kind of has to be your job, right? Because it takes a lot of work to do well. So be wary of, anytime that, and if you're on the internet and you take part in an internet poll, it can be fun to do, right? Something's being figured out or, but just realize it's not very serious statistics. It's not like the kind of thing that you would take very, very seriously. What do we have? I think did we talk about questions? We'll kind of go through the process here. So, internet polls, mail-in polls, telephone polls. This is happening more and more where you get your phone rings, and this is one of the many reasons no one even answers their phone anymore. It's some person who wants you to take a poll. Okay. So most of the time those are not going to be done very well. So don't trust in those. So then what do? Well, we're going to analyze things. We're going to come up with graphs, visualizations, histograms, dot plots, some kind of thing that allows, like a picture that allows me to visualize the data. If you look up statistical papers, like peer-reviewed statistical papers, you will almost always find at least one way of visualizing the data, and probably more, right? Where the author has gone in and looked at lots of visualizations of their data, and they pick the one that they think helps make the argument that they're trying to make. Okay, so you should always have something in there. Look at the graphs. It's easy with StatCrunch now. You literally just say, make the graph like this, and then it does it. And you go, oh, what if I make my bin size different from my histogram? And then it does it. And then you can just play around, and in just a couple minutes, you can have, if you're on your 8th or 9th or 10th iteration of that histogram and you get to one, you go, okay, this looks good. This looks exactly how I want it to look for what I'm doing. Okay. And then you're going to apply a statistical method. So that's a lot of what we're going through throughout the entire semester. We're going to be looking at measures of central tendency, measures of spread, like how spread out is our data? Is all the data points really close together, or are they spread out, right? Where's the center of this thing, which is, a lot of times what students, before they take statistics, think of as the average. That's one way. What they really mean is the mean. That's one way of measuring center. We're going to come up with things called confidence intervals. We're going to run hypothesis tests. We're going to look at correlations and regressions and all these kinds of things. This is basically a toolbox you're building throughout the semester, and then you'll apply those to your project, right? Now, the good news is the way these chapters go is I have you at the end of a chapter, whatever that chapter was about, at the end of that, I have you do the part of your project that applies to, right? So it's not like at the end of the semester you have to, hopefully you remember this stuff, but it's not like you have to remember every single detail. You've already done the work for your project, assuming that you've been keeping up and staying where you're supposed to be. So we apply those statistical methods. Now you have to be careful, right? Common mistake I see is people applying statistical methods to the wrong thing. So there's a couple ways that you can do this. And it's just because the student doesn't quite understand yet what they're doing. But certain types of data that we'll look at, so quantitative data, qualitative data, two different types of data, right? What do you think quantitative might be? It's got that word quantity in it, quantitative. It's amounts. You're counting things, right? How old are you? That's a quantitative question. It's how many years that you've been alive. How many units are you taking this semester? Quantitative. It's counting something. How many hours a week do you work? Quantitative. It's a quantity, right? So quantity, sometimes people simplify it and say, well, quantity is numbers, right? So quantitative data is anything that has numbers. It's not exactly true. You can, one good way of asking yourself the question, if it's quantitative, is can I take the mean of that and have it be meaningful? If we took the mean of people's ages in our class, might that be useful information? Maybe. It might be. I could see instances where we want to know, we're trying to understand the ages of people at our college. Are they all 18 years old? Is it 18 to 22-year-olds? How much of our population is over that sort of 25 group? How many people are in their 30s and their 40s? This can help us make decisions on campus to make sure that we're taking care of our population, right? So in that case, yeah, the age of students, that's quantitative. That would definitely make sense. What if I took all your phone numbers and I took the mean of your phone numbers? Is that helpful? No, because phone numbers, although they're numbers, are not quantitative. They're not counting anything, right? It's like a code. It's not a quantity. Same thing with jersey numbers on a sports team. Would it make sense to take all the jersey numbers and take the mean of those? Nah, how would that be meaningful, right? So in that case, the jersey numbers are really more for identification. They're identifiers. It's almost like you're giving them a second name that's short. It's like one or two symbols rather than a whole name, which sometimes, people's names can be really long. And if you're not used to certain types of names, it's like hard to get the pronunciation right. But if you just see the numbers like 23, you go, oh, I know who that is. I know what player that is or whatever, right? So, so it's almost true that numbers mean quantitative data, but not quite. There are cases, jersey numbers, telephone numbers, stuff like that, address numbers. It's not going to be quantitative. So just ask yourself, is this a quantity? Am I counting how much of something there are? Years, hours worked, units taken at school? Then it's quantitative. Qualitative is more like you're describing the quality of something. Now, in our modern use of the language, quality usually means like good or bad. But if you look at the actual, if you go back a little ways, that's not actually what quality meant. What quality means is just a characteristic of something. What is the quality of it? Is it soft? Is it rough? Is it Is it like rigid? Is it, what are we talking about? Like a blanket. You could you say you're buying a blanket and you would want to describe, well, this is really soft. This one over here is it's a wool blanket. It's kind of rough a little bit. But this one, once it gets wet, it's just soggy, just big soggy mess. But this wool one actually wicks the water pretty well and dries out. You have different qualities of the thing. So like now, whenever we use the quality, people think like, oh, well, this is a better blanket. It's better than the other one. That's not what we mean. When we say quality, we mean a characteristic of. So we're not putting a judgment on the thing. We are just describing something about it. That is called qualitative data, or sometimes called categorical data. So a good example of that would be, this usually comes up in a survey. Although actually, I don't think my other class asked this. Might be the first time my other class didn't ask this. Eye color. What's your eye color? Right? So we're going to imagine what we're going to get if we do that, especially if we broke it down into groups, because some people like to get really fancy with their eye color, like they have some like really specific tone that they call their eye color. But you probably don't care about that if you're surveying people. You probably would just give them choices. What is your eye color? Blue, green, brown, red, right? Some people have like a kind of a red colored eye there. Whatever the colors are that come up, you would just have them, you would check a box. And then everyone goes, that's why it's called categorical data. You're putting people in categories. You're in the category of blue-eyed people. You're in the category of brown-eyed people. You're in the category of green-eyed people, right? So that's a quality. Again, we're not making a judgment about whose eye color is better or worse. That's not what we mean when we say quality. We're talking about quality in the sense of it's a characteristic. The characteristic of your eyes is that they're green. The characteristic of your eyes is that they're blue. We are in no way, we definitely don't want to go down that track, especially with eye color, like trying to say one group's better or anything like that. Will the data survey responses be anonymized or connected with student names? Oh, great question. So yeah, I want to make that clear. And this actually makes it a little bit harder on me. This is one reason why, if I could make taking the survey worth points, we'd get everyone to do it. Like my other class right now is taking their survey and I'm having to push them. Like half the class is taking the survey and I got to push, okay, I can't release the data till the other half of you get it done. So just do it. Just get in there and get the survey done, and then I can release all the data. Otherwise, the class is going to be waiting weeks till we get everyone to take it. Unfortunately, I can't give points because any way that I give points for taking the survey will leave you identified with your answers. And, usually if you want people to be honest in a survey, you probably don't want them to be identified so that you can go back and go, I know who this is, right? Sometimes you can, but you're not going to have like your name in there. It's not going to say who you are. So I definitely want to respect people's privacy because then they're more likely to go in and take the survey. So the survey will not be traceable back to you as far as an identifier. Now, one of the first semesters when I did this, we had a woman in the class who was almost 70 years old. So when the question was asked, how old are you? Well, there's only the person who wrote whatever she was, 68 or 69 or 70, or I don't remember her exact age, but everyone knew whose responses those were, right? And she was cool about it, but everyone knew, oh, I know who this is. So you want to be careful. So that's a really good question. In case you didn't catch it, I'm reading a question from the chat here about the anonymous responses. So yes, assuming that, if we have someone in the class who's 7'2", and then they answer the question about height, we're all going to know who it is because there's one person who's 7'2", right? But assuming you don't have anything that totally stands out, there won't be any way to identify you. Plus, none of you are going to, most of you won't ever actually see each other anyway, so it's a little easier to be anonymous. But you shouldn't, outside of that, outside of your answers themselves, giving yourself away, you won't be identifiable. And that's good because, if there's questions on gender or there's questions on, sexuality or anything like that are obviously still within the bounds of like being professional, not like getting weird or anything. But if anyone wanted to ask questions about that, that's the kind of stuff that some people might not feel comfortable sharing. So, you should understand that people won't be able to look at it and go, I know who this is, because look, their name's right here in the survey. It's not going to show up in the survey. So they still will be anonymous. Now, again, the thing that takes us to is it's harder for me to get everyone to take the survey, because since it's anonymous, that means you don't get points for taking it, which means some people take a lot of extra time to do it, which holds back the rest of the class who's trying to continue with the survey. Okay. Now, and that brings up a good point. There are times when people will answer your survey questions incorrectly, intentionally, and or unintentionally, right? So for instance, if you ask a question about gender, if you're in certain parts of the country and you ask someone a question about gender, they may fear, if I answer this question wrong, it could actually affect my safety afterwards. Like if I give this answer and then someone's able to figure out who I am, maybe I will face persecution after this. So then that person may not answer honestly, because they're concerned about their own safety, right? So that is definitely a concern. So it's a great question that was asked. That is a concern when you give out a survey is, can I truly make this anonymous and make sure that I'm protecting the people who are willing to be part of the survey? Can I step forth and say, yes, this is safe. You can answer honestly. So there may be reasons why people intentionally give wrong answers. Sometimes it's for good reasons. Sometimes it's for not, right? I would say if someone is concerned about their safety, I can kind of understand why they would not want to answer questions then, because none of us want to be in unsafe conditions, right? None of us want to be harassed for things that we're doing. So that's a very legitimate concern, is safety. There's other times where people may answer incorrectly for lots of different reasons, intentionally, like people's feelings about themselves. You ask people about weight. Weight is a whole weird one. If you ask people's weight, which generally doesn't come up in our classes, I think, because most people kind of know it's sort of an odd. When you ask people about weight, there's a lot of baggage that comes along with it. But notoriously, if you ask people their weight on a survey, you're not going to get great answers for a couple of reasons. One is that a person might not feel good about their weight. They might not want to share that weight with people who, again, can identify who they are then or figure it out in some way. Or a person might feel bad about their weight, and so it makes them feel bad to put down the proper weight, so they put down a small number. There's lots of things that can go along with that. Also, the fact that people's weight kind of varies on a daily basis, right? One interesting thing about weights is if you ask weights, if you just ask people in a survey, what is your weight? You're going to get almost no odd number answers, which is weird. So people do one of two things when they're estimating their own weight. They either give an answer that ends in a 0 or a 5, right? Oh, I'm, whatever it is. I'm 175 pounds, or I'm 170 pounds, or I'm 180 pounds. Those are the kind of responses you get. There's another large group of the population that will always go in twos. I think I'm 174. I think I'm 172. I think I'm 170. Right? They put answers down like that. When you see that, though, as a researcher, most of those answers are just estimates, right? The person didn't go weigh themselves. They estimated what their weight was. Right, because you won't see a lot of 171s and 173s and stuff like that. Those odd numbers don't show up as much. So notoriously, if you're doing work where weight is important, you probably need to weigh the people like yourself. You need to have them come in, they stand on a scale, you write down their weight, and then they move on. Because if you leave it up to people to answer that question, your data is not going to be great. And you can tell just by looking at it. When your data comes in, right, there's a scene. Remember, those of you who have watched Ozarks, remember early on in the show, there was a point where I forget everyone's name since it's been so long since the new episodes have been out. But the main guy, the Jason Bateman character, he figures out early on that the paperwork or the accounting work that he's supposed to look at is fake. He's looking at it going, these books are cooked, which basically means they're lying, right? They're hiding money. How was he able to do that? How was he able to look at it and go, this doesn't seem right? And I don't remember the detail for that, but you can look at data a lot of times and you can figure out, and they have actual software that will do this as well. It's even more sophisticated than a human, but they can look at data and go, this data is incorrect. If I ask people in this class, what's your weight? And every single number that comes back is an even number, no. There's the probability that out of 40 people, no one weighs an odd number of pounds. Very unlikely, right? So that's kind of an extreme case, the example that I'm giving you. But you can definitely do this. People try to fake data sets all the time, and they get caught because a lot of humans who do this on a regular basis can look at a data set and go, that doesn't seem right. And there's actually advanced formulas in mathematics. It's weird about the leading number, like the first number in a data set. You'd kind of assume you'd get all of them, right? That it would be equally distributed, 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, like that. But it turns out they're not. In other words, a lot more numbers start with a 1 in data sets for some reason than start with other numbers, usually. It doesn't hold every single time. So, but people can write software programs and you run this data set through and they can go, this is pretty unlikely. And then they can catch stuff. So, this is why a lot of people who cook the books for their, they try to move money through and they try to hide money, basically embezzling. I'm going to hide money and sort of siphon it off for myself and no one's going to see where this money goes. There's a lot of tools that can catch those values because it's harder to cover up your tracks than people think it is with that kind of stuff. And part of it is because we a lot of times can predict what data sets are supposed to look like, right? Of course, like in stats, there's always something that breaks the rule, but usually with data sets, it follows some specific behavior. So it's hard to fake that stuff. Let's see, where am I? Oh, and your questions. So questions are tricky, right? I know out of the gate we're talking about all this stuff, and it sounds like it would be impossible to run a proper sample, right? A study or an experiment. Remember, we talked about this last time, I think. A study is where you just watch something occur. Study is where you just watch something occur. An experiment is where you change something. So a study would be you're standing at the street lights timing the yellow lights. An experiment would be you've got a placebo, you've got a vaccine. Some people get the vaccine, some people get the placebo, right? You gave people a medication. That is changing what you're watching. You as the observer are actually changing the course of events. And that's okay, but you should kind of know which one you're in, right? So when you ask questions, it can be very, very difficult to ask questions in a way that is non-biased. And we always want to do that. We want to eliminate bias, assuming you're doing things ethically, right? This comes up regularly because statistics is used so much to be dishonest and do things in an unethical way. A lot of the statistics you hear in news and having to do with politics and business and stuff like that, a lot of those statistics are intentionally misleading. People have set them up to make you think a certain thing, and a lot of times that stuff is intentionally done with a lot of bias, so you can make things come out a certain way, right? For many, many years after it was well understood that smoking was dangerous, you still had the cigarette companies releasing work saying, our work shows it's not dangerous at all. We think it's fine. We don't think it's addictive. We don't think it's dangerous. Well, all that work was completely biased, right? For lots of reasons. The people doing the work knew if their results came out wrong, they wouldn't have a job much longer. All those people understood how the statistics were supposed to come out. The current one that I'd say you can see is climate change, right? Scientists overwhelmingly agreeing on how climate change is working. Or how it works. And sure, there's updates because each year we get more information, and that's how science works, is each year science updates and says, oh, we know a little more now than we did last year. But there's lots of work being done intentionally biasing that to sort of try to be the part counteracting the whole climate change argument, right? But if you look at most of that work, it does the work that is sort of trying to say that climate change isn't real or whatever. If once you dig into that, you'll see there's usually some flaws going on there. So this kind of bias, you want to eliminate it. Even if you really feel strongly, like, I really think this, you'll see this in teaching. I really think this way of teaching is beneficial. I think it's a better way of teaching. And then you try to run some kind of study to see if the class who did this way of teaching did better than the class who didn't. You're going to have this bias in you because you really believe this is the right way to do it. And that can affect what you do along the way in a way where maybe your work doesn't hold up because you were a little bit biased. Even though you were trying to be fair, you can still be biased, right? I've literally watched this happen in education where people do things where you kind of go, that seems a little sketchy. Like it seems like you're kind of forcing the outcome that you want. That's not what you want to do. You want to try to be ethical. You want to try to do the right thing, right? Ultimately, hopefully, when you're doing statistics, what you're after is truth, not trying to make a buck, right? I mean, but you're all going to live your lives. You'll have to decide what you want to do with it. So lots of ways in which the way you ask a question can be misleading, right? So here's an example. Should the president have the line item veto to eliminate waste? Or should the president have the line item veto or not? Well, when asked, should the president have the line item veto to eliminate waste, 97% of people surveyed said yes. Should the president have the line item veto or not, 57%. So essentially, you're still just asking, should the president have line item veto power? That's really what both questions are asking. But notice that first one, when it says to eliminate waste, all of a sudden, you're bringing in people's emotions. You're bringing in their feelings, and that starts to cloud their ability to answer that question properly, right? You could imagine a similar survey question now asking, do you support your tax dollars going to social programs? Just that, going to social programs. Or, you could ask the question in a way, do you support wasting tax dollars on helping people who don't want to work or something like that, right? You could imagine with the way our country is politically, you could imagine asking a question in a way that's going to get people emotional and get them riled up, and they're going to answer that question a little bit differently, right? So what you want to do in your questions is just like kind of a plain, boring question. You don't want to bring up stuff that's going to get their emotions running. You don't want to bring in stuff that's going to trigger their like political alignments so that they're like, there's certain phrases in there that, oh, this is like about climate change. I'm this party. I better answer this question this way so that I'm not like betraying my fellow party members. You don't want that kind of stuff. You just want to put the question out there as simply as you can that gets your question answered. The order of questions can mess things up. You ask things in a different order. You got them thinking about something in question 5, and it kind of stuck with them. That emotion that you built up in question 5 is still with them in question 10, which is a similar question, and then it gets them to answer that question a certain way. If you reverse the order, you can get different outcomes, which makes it really tricky, right? There was a famous case that was big in the news. This was a while now. This must have been I don't know, what would that have been, like 7-8 years ago? Actually, I think it was a few years after that came out. So it was maybe like 4 or 5 years ago. So there was a survey that was done of people, and there was 2 questions on this survey. One question was, what is your favorability rating of the Affordable Care Act? And then there was a question, what is your favorability rating of Obamacare? Okay. This is the same question because the Affordable Care Act is the official name of the nickname that the GOP gave to Obamacare. They call it Obamacare, right? So it's the same exact thing. But when people were asked in the same survey, when people were asked, what is your favorability rating of the Affordable Care Act? Very high scores. Like people were like, this is great. This is the greatest thing ever. When they were asked their favorability of Obamacare, very low. very low scores. So you see what happened there with that question? It was triggering that bias. That political affiliation was getting dragged in, and then it got people thinking about it different. Plus, a lot of people don't even know those are the same thing. But you see how you want to ask a question in a way where it's not going to get those political ideologies coming in. It's not going to get people emotional or feelings involved. You want to try to ask questions in a way that is just like, the questions really should be kind of boring. What is your age? How many units are you taking this semester? Just a way where it's not like you're not tying it into things and trying to get, otherwise you're kind of leading people to a certain answer. And that's not what you want to do in ethical statistics. You want your answers to be the truth, unless you're trying to be unethical. That's a possibility. But hopefully we're all doing sort of ethical statistics here. Okay, looks like I'm out of time. That kind of got us through some of the early basics, kind of understand the basics of how we should be asking questions and moving through things. Again, a lot of this will sound similar to what you're seeing in this first chapter, right? Hopefully I believe I've said some things that aren't exactly covered in those videos that you're working through, kind of broadening that picture, maybe giving it a little bit more color so you understand it at a deeper level. And that's what we'll be continuing with that. So early on, I'm really hitting the basics, because if you don't understand the basics in statistics, it's really hard to get the more complicated stuff, right? So, okay, so I'm out of time. I'll shut down the YouTube stream. Anyone who wants to talk to me in Zoom, I'll stick around as long as people are wanting to talk to me in Zoom. Those of you who have not signed up for the online access yet, do it. You have two steps. One is just signing up for the free one, which only takes a few minutes, like the free temporary one. Then work with the bookstore to get your permanent free one, right? Why wait on free? It's free. It doesn't cost anything. Go take care of that. I haven't heard any complaints. I haven't heard students saying they're having problems with that. So I assume everything's working well. Strike while things are working well. If they run out of licenses, you may end up buying one. So do that. Stick around if you want to ask me questions, and I will see you, what is today, Wednesday? I guess I'll see you next week. Okay, so watch those due dates.